welcome back to Burns' Math Club. Today we'll be learning how to solve systems of linear inequalities. In our previous videos, we learned how to solve systems of linear equations. The concept is pretty much the same in both. However, when you have a system of linear inequalities, you will have the inequality symbols, which are greater than, less than, greater than or equal to, and less than or equal to. The first step in solving a system of linear inequalities is to put it in slope-intercept form, which is y equals mx plus b. As you can see, both of our inequalities given are already in slope-intercept form, so we can go ahead and graph. Remember, when you're graphing in any inequality or any equation, you need to go ahead and graph the y-intercept first. The first equation has a y-intercept of -2, so we will graph -2 on our graph. So -2 is right here. So we have done the y-intercept, and now we're going to do the slope, which is -x. -x is the same thing as -1 over 1. Remember, slope is rise over run. So whenever any number does not have a denominator, it means it has a denominator of 1. So -1 over 1 is our slope. That means we're going to go down 1 and then to the right 1. Down 1 to the right 1, and continue this until we cannot plot any more points going this way. Now that we've finished plotting points on this side, we can always continue by flipping, in a way, the slope. So when you had -1 over 1, we can always change it the opposite way and make it 1 over -1. So now we can graph the points on the opposite side. So we have up 1 to the left 1, up 1 to the left 1, up 1 to the left 1, and then just continue this on for the rest of the graph. Alright, so we have graphed our first linear inequality. Now remember, when you have a greater than or less than, or greater than or less than or equal, greater than or equal to, or less than or equal to symbol, your line will be solid. And when you have a greater than or less than symbol, you're going to have a dotted line. In this case, we have a less than or equal to symbol, so it will be a solid line. So it's going to go down like this. Alright, so we've graphed the first one. Let's go ahead and move on to our second inequality, which is y is greater than -5x plus 2. In this, our y-intercept is +2, and then we have a slope of -5 over 1. So we'll go down 5, 1, 2, 3, 4, 5, and then over 1. Again, 1, 2, 3, 4, 5 over 1. We can't go this way anymore, so we can always change this over to 5 over -1. So now we will go up 5 and then to the left 1. So 1, 2, 3, 4, 5 over 1. And we have our line. But, however, I forgot. So we have less than or greater than, and remember, this cannot be a solid line because this has to be a dotted line. So a dotted line is basically just going like this. So it's making a distinction between greater than or equal to and less than or equal to, and greater than and less than. Alright, now that we have graphed both of our linear inequalities, we can go ahead and find our solutions. So as you can see, the first step that we did was graph them, and then we graphed the second inequality as well. Now we know that there is a point in which both of the lines intersect, but this is a system of linear inequalities. Therefore, we will not only have one solution, or one pair of solutions that will satisfy both inequalities. We're going to have a variety of solutions. Now what we have to do is shade the region in which our solutions will lie. First, let's go ahead and shade the regions for the first inequality, which is y is less than or equal to -x minus 2. The less than or equal to symbol says that all the solutions to that inequality are going to lie underneath it, because less than, that means we're going to shade down. So we will shade this way over here. And this is where the solutions to this inequality lie. Same thing we're going to do for our second inequality, which is y is greater than -5x plus 2. Now, the first inequality, it was simple to say what's going to be the top of the inequality and what's going to be underneath, right? But for the second one, as you can see, it's kind of hard to determine what's the top and what's the bottom, We can always satisfy or clarify this by finding any point. So let's say that we think that it's going to be the right side that's going to be the top, because remember, if it's greater than, you have to shade to the top. Let's say that we choose the point 1, 1. So it's over here. So we have 1 and 1. And plug this into the inequality, we can see if it's going to be true or not. If you have 1 and then is greater than -5 times 1 plus 2, we get 1 is greater than -3. And we know 1 is greater than -3. That means we were right. And so when you shade this, it is going to be to the right side of the inequality. And so this is where you will shade. As you can see, the point in which, or the part of the graph in which both of the inequalities are intersecting and shading is this part over here. And this is our part of the graph in which the solutions lie to both of the inequalities. That means any point in this part of the graph can be a solution to these inequalities. So this is it, how you solve a system of linear inequalities. Thanks for watching this video, and we will see you guys next time. Bye!